Hello and welcome to another video on Lab 2. This one is going to deal with contour analysis and also streamline analysis. So we're looking at analyses, and we're going to start out with contour analysis, which deals with scalar fields, whereas streamline analysis will be with vector fields. So we already talked a little bit about scalar analysis, or scalars, and scalars are just numbers. These are numbers on a map, and they just have magnitude but no direction. So what you do with contour analysis is you draw lines that connect points, typically of the same value, to make a pattern, to figure out what the numbers represent. Where are there bigger numbers, where are there smaller numbers, and these lines help you identify these patterns. So they kind of give us a configuration of these numbers. And we use something called isopleths, and isopleths are only used for scalar fields. We'll talk about what you use for vector fields later. Isopleth comes from the Greek words iso and pleth, which means equal and value, so these are lines of equal value. So by definition, lines of equal or constant value at any particular time. And there are a lot of different isopleths. You probably are familiar with some isopleths that you've drawn before back in other meteorology classes, such as isobars, which are places where meteorologists go, but also they're lines of constant pressure. Isotherms, you've probably seen lines of constant temperature. Isotachs are a little bit more esoteric, but we use those in looking for the jet stream. They help us identify areas of constant wind speed and help us find stronger winds and weaker winds. Other ones like isogons is what happens after you've been to the isobar, which are lines of constant wind direction. You don't see those very much. Isoshear for wind shear, which is used in upper level analysis near the jet stream. Here's one of my favorites, the isodrosotherm, which is lines of constant dew point, and we actually do draw isodrosotherm. Other ones, isohyates, areas of constant or lines of constant precipitation amount. Typically you'll see these drawn whenever there's a very heavy precipitation event. Isopicnics, I hardly ever see any isopicnics, but they're lines of constant density. Isohumes sometimes are drawn, lines of constant humidity. Isentropes, which we will use, believe it or not, more later on in this class, but the lines of constant potential temperature. If you remember, we said that isentropic analysis is another form of vertical component. We talked about height, pressure. We also talked about sigma coordinates, but then also theta coordinates, which are isentropes. And then a couple other ones that are used actually frequently, isalobars, which are lines of constant pressure tendency, which means how the pressure is changing over the ground. And then finally, contours are used to represent lines of constant height. In this lab, we'll be drawing mostly contours on 500 and 250 millibar charts. So that was contour analysis. We're going to talk about streamline analysis now. Streamline analysis deals with vectors, whereas contour analysis was with scalars. So what you do with streamline analysis, you draw lines that are parallel or tangent to any point in the fluid where you have some values or some vectors. And it gives you instantaneously the representation of the fluid flow. So as I mentioned, this is an analysis of vector fields. And it has some examples of streamline analysis. Here's one. You can see the lines drawn here are streamlines, and then you see wind barbs. And notice that wherever you see a wind barb, the streamlines are parallel to the wind barb at that point. You'll be drawing a streamline analysis in this class, and just remember that the lines that you draw need to be parallel to the wind barbs or the wind vectors. Not only that, but also streamlines are allowed to diverge or to intersect. And you can see some of that around the swirl on this map. But here's a better one. This has a lot of wind barbs or wind vectors, and you can see over Wisconsin how they're converging together. And actually that's very useful. It helps us identify areas of convergence. And then where it swirls around, that identifies areas of low pressure or high pressure. Remember, with low pressure, air usually converges in towards the center, and high pressure, wind usually diverges and spreads out from high pressure systems. So that's just a quick overview of streamline analysis. One other thing I'd like to mention is that streamline analysis is very useful in places where you have very weak pressure gradients. And one of those locations is in the tropics. And streamline analysis is done in the tropics to help identify tropical waves that help form hurricanes and typhoons. So that's all I have for you for this video.